Let's go ahead and take a look at the graphs in the library of functions. The first one we're going to start with is our constant function. And this one's going to be in the form y equals b. B in this case can be any number. And in the example that I have graphed, I'm going to go ahead and use the equation y equals 3 for right now. And let's go ahead and take a look at 3 key points that are on this graph. Our first one is going to be our y-intercept. So this is going to be the point 0, whatever that b value is. So one of our key points is going to be 0b. And you're going to notice that it doesn't matter where we come out, left or right, onto this graph, on this line, right? Another point that is on this graph is going to be the point -1, b. And I'm also going to have the point 1, b. Now obviously you can pick a few other points. You can use 2b or 3b as coordinates as well. You just want to make sure you have at least 3 key points that we can work with on this parent function. And let's go ahead and take a look at the domain. We want to know how far left and right our graph goes. You'll notice the arrows on the end of this graph, so it's going to be going left and right forever. So this graph is going to have a domain from -infinity all the way to +infinity. And if we take a look at our range, we want to know about the y values on this graph, or how far up and down our graph goes. And for right now, the only y value that we have is whatever that b value is. So you have a couple different ways you can write this range. You can write it as y equals b. You can also use the set notation and put that b value right inside those braces. Or if you're doing something on paper and pencil, I'll also accept that b value inside a single set of hard brackets. Our next graph is going to be the identity function, which is the graph y equals x. Let's go ahead and take a look at some key points on this graph. You'll see that we have an intercept here at the origin, so one of our points is 0, 0. We also have the point 1, 1 on our graph. And we also have the point -1, 1 on our graph. We'll go ahead and use these 3 points as our key points. Obviously, you could also pick something like 2, 2 or 3, 3. Let's go ahead and look at the domain and range of this function. Domain is how far left and right our graph is going. Notice you have arrows on the end of those, so it's going left and right forever, which means our domain here is going to be from -infinity all the way to +infinity. And our range is how far up and down our graph is going. We're taking a look at the y values here. Our lowest y value is going to be at -infinity, and this is going to keep going up all the way to +infinity. Our next graph is the square function, which is the equation y equals x squared. And if we take a look at 3 key points on this graph, you'll notice that we have a point here at the origin, so we have the point 0, 0. We also have the point 1, 1. And we have the point -1, 1. Those will be the 3 key points we use on this graph. Obviously, you could use something like 0.24 as well if you would like to. So let's go ahead and take a look at the domain and the range of this graph. Domain, we're looking at how far left and right this graph goes, and it's going to go on forever in both directions. So we're going to have a domain from negative infinity to positive infinity. Our range, we'll take a look at how far up and down the graph goes. Our lowest y value here is a 0, and that point is defined on our function, so we're going to be able to go ahead and put a bracket on that 0. And it's going to be going upward forever, so all the way to positive infinity, and infinity always gets a parenthesis. Now let's go ahead and build in a couple extra components here. We'll take a look at where the graph is increasing and decreasing as well, just so we can get a little bit of review in. Keep in mind when your graph is increasing, that's where it's going uphill as you look at it from left to right. If it's decreasing, that's where your graph is going downhill as you look at it from left to right. So if we take a look at our graph here, you'll notice that this whole section is where our graph is decreasing. And if you want to go ahead and highlight your graph, or if you want to go ahead and mark it up, you can go ahead and do that. So here's our decreasing section. Let's talk about that as an interval. Right? Our lowest x value there is from negative infinity all the way to 0. And I'm going to leave these as an open interval, so I'll go ahead and use parentheses for this part. And then once it hits 0, our graph is going to go ahead and start increasing, and it's going to keep increasing forever. So here's our increasing section. So we want to write this as an interval. Our smallest x value here is a 0. And our largest x value there, it's going to be going on to the right forever, so positive infinity. And I'll do the same thing. I'm going to list these as open intervals. Anytime you see that phrase, you can go ahead and just use parentheses for your interval piece. Our next graph is the square root function. And we're going to be taking a look at the positive square root of x. So let's go ahead and identify 3 key points on this graph. We have a point here at the origin, so we can go ahead and use 0, 0. We have the point 1, 1. And we also have the point 4, 2. Right, these key points are any coordinates that would make the equation true, right? So if my x value is 4 here, right, think about what happens when you take the square root of 4, you're going to get 2, which is the y value for that point. Right? So let's go ahead and take a look at our domain. For the domain, we want x values, so our smallest x value is a 0. We can go ahead and put a bracket on the 0, since we're allowed to count that point. And our x value here, farthest to the right, this graph is going to go on forever, so all the way to positive infinity. If we take a look at the range, we're taking a look at the y values, so how far up and down our graph goes. Our smallest y value is a 0, and it's defined there, so we can go ahead and use a bracket. And this graph will be going upward forever, so all the way to positive infinity. And let's go ahead and take a look at where the graph is increasing and where it's decreasing. Remember, increasing, it's going uphill as you look at it left to right. Decreasing, it's going to be going downhill as you look at it left to right. Let's take a look at our graph here. This whole section, right, is where our graph is increasing. It's going uphill as we look at it. So our interval here is going to be from 0 all the way to positive infinity. And I'm going to go ahead and use open intervals for this one as well. Just means I can go ahead and use parentheses. I'm not so much worried about the endpoints. Our graph is not going downhill at all, so this graph actually has no intervals where it is decreasing.